Okay, so today we're going to talk about radicals and what their graphs look like. So first of all, this right here is my most basic radical function. Again, the most basic radical function is called the parent function. Okay, so if I went into Desmos, do y equals the square root of x. And this is what our function is going to look like. Okay, so a couple things I want you to notice is there's not a lot of nice points. Remember, nice points are those points that are right directly on the crisscross in the graph. Okay, so what we want to do is we definitely want to get our starting point. So as you can see, my starting point's at the origin. It's at 0, 0. And then we have another point at 1, 1. And another point at 2, 4. Okay, so all those points are going to go into our table. So we had 0, 0, 1, 1, and then what was it? It was 4, 2, not 2, 4. So if we graph these on the graph, we would have a point here, a point here, a point here, and then remember, these are continuous, so we want them to keep going. Okay, so let's talk about the domain. Remember, the domain are the x values. They go from left to right. So if I look at this domain, okay, the domain are just the x values. If I'm looking, I'm starting my domain here. Okay, there's not any points to the left, and I'm going towards all those bigger numbers. Remember, those bigger numbers are called infinity. Okay, so again, we're starting at 0. We're headed towards infinity. We're going to put a bracket on the 0 because that is part of the graph. Okay, that is one of our points right there on the coordinate grid. But we're going to put a parenthesis on the infinity. Again, infinity is a concept. It's not a number. So we want to make sure that it's not going to be included. Okay, so that's why we put the parenthesis there. With the range, remember the ranges are the x and y, the ranges are the y values. So again, if we look at our y-axis, we're starting at 0, and I know this is weird, but it is pointing up. This graph will continue to go up, 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 up as it goes off of our grid. Okay, so again, our range is going to start at the origin. It's going to start at 0, and it's also going to go up to infinity, because remember, positive numbers go to infinity. Bracket on the 0, parenthesis on the infinity. Okay, so we need to think about what values we can't plug into the x from the table above. X cannot be negative. Okay, if it's negative, if we have a negative under the radical, remember our numbers would be imaginary. So the domain for the range is going to be all non-negative numbers. Okay, and again, this is our parent function. It's the most basic radical graph that we have. Okay, so moving on, I said that. Okay, we're going to talk about what it looks like to have some of these transformations. Now, we talked about transformations in our quadratics unit. So this is going to be the square root of x minus 5. So let's take a look at Desmos. We'll add another one. We'll do y equals the square root of x, that minus 5. Okay, and let's look at our graph. Do you see how the graph, it looks like the same shape? However, it's going down 5 units. Okay, so why is it going down 5 units? It's going down 5 units because of this negative 5. Okay, so we know that this is going to be the same as the parent function, but we're going to move this graph. Okay, So it's going to be translated 5 units down. Okay, so if we grab our X and Y table, all right, instead of it being 0, 0, it's going to be 5, 0, negative 5. That right there, that's our starting point. And so our starting point on the graph is going to be right here, okay? And then I already have some points from it, but you can go to Desmos and grab your points. So 1, negative 4, and then another point would be at 4, negative 3. So these are all the nice points in our radical graph, okay? So with our domain, okay, the domain again is the X values. So we're starting here at 0 still, and we're going towards all those positive numbers. So the domain hasn't changed. The domain's going to be the same. However, the range. Now, the range at the above was starting at 0, but now it's starting at negative 5. So it's going to be from negative 5 to infinity. Okay, and I hope you guys see some patterns here, okay? The pattern here is the 0 is the domain, that starting point. It's that same. And that negative 5 is going to be this from the starting point of the range. Okay? So let's take a look at this one. This one over here is going to be a little bit different, okay, from that parent function. Why it's going to be different is because we have a negative there. And if you remember from quadratics, the negative tells us to reflect. And the 2 tells us it's going to vertically stretch. Okay, remember 2 is bigger than 1. That means it's a stretch. Okay, so let's look at Desmos. Let's see what this graph is going to look like. So I'll get rid of this one. Do negative 2. Okay, now looking at these graphs, okay, the blue one is my new graph, so see how it's facing down, and then it's being a little bit more stretched. So instead of it being at 1, 1, it's going to be at 1, negative 2. Okay, so let's go ahead and graph these points. Okay, so if we got some points from our table, again, you can get these points from Desmos. Okay, so we're starting at 0, 0. We're going down this time and down this time again. This is a negative in front, so it's facing down, and then it's being stretched. It's almost like a rubber band, right? It's being stretched down. Okay. So let's look at the domain. Again, I'm hoping you see these patterns. That starting point right there is going to help us with the domain and range. So the domain is going to start at 0 again and go towards infinity. Again, start at 0, it goes that way. Okay, now the range is going to be what's different because, again, it's starting at 0, but it's going down this time. Okay, it's going down towards negative infinity. And if you remember from when we talked about this interval notation, we have to go from lowest to greatest. So this negative infinity is going to go first, and it's going to start at 0. So that's what that's going to look like. Okay. So let's look at this one right here. Now this one is different because that +2 is on the inside. Okay, so if we go to our Desmos and we take a look and see what this graph looks like. Okay, So notice our graphs look the same, but look what happened. It went to the left too, okay? Remember that when we have an H value, which is what this is, an H value, okay? This is going, so it's gonna be translated 2 units left. Again, H is opposite. Okay, so I'm gonna grab some points from my table. I'm actually getting them from a calculator, but you can get them from, you can get them from Desmos, or you can plug them into your equation. Okay, so this is gonna, what this looks like. All right, so again, here's our starting point. So let's talk about what this domain and range looks like, okay? So the domain comes from the x values. Now it's going all the way to infinity, okay? So it's going to be -2 to infinity. Bracket on the -2 because it's included in the graph. All right, and our y value is going to start at 0 and it's going to go up towards infinity. Okay, so that's how we graph them. That's how we do our domain and range. All right, so let's go ahead and take a look at some of these right here. Okay, so we just learned from the last function that adding and subtracting values outside the radical translate the radical. So if they're outside the radical, that's our k value. So remember, this is going to be y equals a x minus h plus k. Okay, this is the same thing except in the inside here was we had a squared instead of a radical. So that moves the function up and down, and adding them inside of the radical moves them left or right. But remember, inside is opposite. Okay, so if we look at this one right here, that's x minus 3. So that's inside the radical. So -3 tells me I'm going to go to the right 3. Which graph goes to the right 3? D. So that's graph D. And then this is on the outside. So this is going to move down 3 because it's on the outside of the radical. So that would match with graph B. Okay. This one right here, that 3, remember that 3 is bigger than 1, so that's going to be a stretch. That's actually going to match up with graph C. And then last but not least, that negative tells me it's going to reflect down. So A is the only one that's reflecting down. In addition to that +3 is moving it to the left 3. Okay, so that is a lot of what this lesson is going to be about, is just transforming these functions. Okay, we have talked about this before, so I'm hoping you guys are a little bit comfortable with this concept of having that h value. Remember, the h value is horizontal. This is opposite. Okay, so if it's a plus h, it's going to go to the left. Minus h is going to go to the right. K goes up and down, plus k goes up, minus k goes down. Okay, and then we have a vertical stretch or compression. Remember, if A is bigger than 1, it's a stretch. If A is in between 0 and 1, it's a compression. Okay, remember that's the absolute value of A, so it means that we're just talking about the positive numbers. Okay, because the negative is going to what tells us to reflect. This B right here is not something you need to know for this class, but it's a horizontal stretch. So instead of you pulling the radical up or down, it's pulling it sideways. But again, you don't have to know that for this class. Okay. So that's pretty much it for these functions. One thing I do want you guys to realize, however, is that all of these functions are the same. Okay. If it's something on the inside like here in number 4, if it's something on the inside, that's going to move left or right. If it's something on the outside, like numbers 4 and 5, those are going to move up or down. Okay. A function like number 5, that's 1/2 in front, that's the a term. So it's less than 1, so that's going to be a vertical compression. And number 6 is has a 3 in the a term, so that's going to be bigger than 1, so that's going to be vertical stretch. Okay, so these go with all functions, every single function. So for example, if I had a cubic function, okay, which a cubic function looks, where can I get some empty space here? Yeah, right about here. A cubic function looks like this. Cubic function is y is equal to a, it's the cubed root, x minus h plus k. Same situation, okay? Absolute value. Okay, all of these functions move in the same way. The a either is a reflection, or it's a vertical stretch or a vertical compression. The h value goes left or right. The k value goes up or down. Okay, that's it. Any function in the world. We've talked about radical functions. We've talked about, remember this was the quadratic one, a x minus h squared plus k. Okay, we could put any, we can make this a, not a quadratic. We can make it a to the 5th power, x minus h to the 5th plus k. All these ah and k's are going to be the exact same.